All right, ladies and gentlemen, I want to say a big welcome to all of you with application of descriptive statistics and even more, including visualizations in Python, but we are using Jupyter Notebook, okay? I've already given you a lot of information as to how to download the Jupyter Notebook. We are going to do all of the following, all the location, the measures of central tendency, the spread, the variability, the dispersion, the ketosis, the skewness, all of these measures. And we shall be using the PIMA data set. Okay. This is a data set that you are all aware of. But before we start using Python, let's try quickly to remind ourselves what is Python. You've done it already. I want to believe that. It's a programming language. Basically, it is like R, okay, R software. Now, next semester, I'll be taking you through some applications using R as well. And like C++, like Starter, like SAS, all of those, MATLAB, all of those things are programming languages. And this one lets you more quickly integrate your systems effectively. Okay. R is dedicated for statistics. Most of the time, R is good, but then Python is general purpose language. You know, Python is doing a lot, and you're going to see this with the interface. It is beyond the statistics. You can use, for example, Python to develop websites. You can use it to develop a software. You can use it to task automate, to do data analysis, data visualizations, and all of that. Programmers who are not experts, programmers, like accountants, lawyers, doctors, you know, they like using these things a lot. But we know that R is also very good. R is like for a lot of mathematical programmers, people with high academic, you know, enjoyment. They like those R a lot. But Python builds complex analysis pipelines with a lot of mixed statistics. For example, you can use Python for image analysis, for text mining, control of physical experiment, and all of that. So, how do you get Python? How do you get it? How do you get Python? Well, one way you can get it is go to the Python website and go get it. But that will mean that you would need an interface to run it. And this interface could be separately going for PyCharm, you know, or going for another one like Spider to run it. Or you can rather go to anaconda.com and get the entire package, which includes all of it. So that the Anaconda is like a whole distribution of the Python plus other programming languages like R, like, you know, all of those other things. So once you go there, you download it from there. This video will show you how to do that. So please watch the video. And I know most of you have already done that. Once you download it, you can navigate around the getting started. You can check whether the library has been installed in Anaconda. Okay. And one way to start the Anaconda is by opening it on your desktop. You go to start, you type Anaconda, it will pop, you open it. And once you open it, you get an interface like this. I have a short video here that will show you how to, you know, get started with using it. What you have to do is that once you open it, you have this interface. You click launch because we are going to use Jupyter Notebook. Remember, you could have also used R, you could have used Spider as we are here. You could use PyCharm, but the best we are going to use. And you see why we are using Jupyter Notebook. You see why Jupyter Notebook is good. Because it's like Microsoft Word. It has other things called Markdown, which you use to do your own typing, bold things, italize things, and those stuff. So it makes it more interactive. That's the whole thing. It's web-based, you know, and it's interactive. Some people think that you need the internet to use it. You don't need an internet to use it. That's a beautiful thing. So once you launch the Jupyter Notebook, you will get the interface like this. You will get this for the first time, okay? And I want to go, and I want you to do that, please. Go to your Jupyter notebook, launch it. You will get the interface like this. The interface will go to your computer, and it will try to show you all the things on your computer. Things like, objects, all of those things, your desktop, my documents, my downloads, everything on your computer, you will have it in a form of that. I'm going to do that right now here so that you can see. Okay. So normally you will have it like this. You will have the interface like what you see on my screen here. So what do? First timer, you click, because you've not used it before, first time, you click on the top right, new, and choose Python 3. And that will open the kernel. I'm going to do that now. So I do this, and then you open your first sort of notebook. Okay, this is your first sort of notebook. Now at the top there, you have not titled it, so you can click on it. Let me go back, click on titled, and then you can give it a name. So let's just call it business analytics. Okay, business analytics. You can give it any name. You can give it even your own name. Okay, and then you click rename. So at the top now you can see that the name of the document is called Business Analytics. Let's start your first thing. Now, what you see here is known as a code, a code, an interface for you to type your codes. And anytime you want more, I like to type many of them. I like to create many of them because you'll be typing a lot into this typing code. And to create that, you click Insert Cell Below. Once you click Insert Cell Below, another one will come. Once you click Insert Cell Below, another will come. Once you click again, once you click again, once you click again. So you have a lot of things down there. You can go back and click on the first one, and then you can put in your first code. So I want you to do that. Yes, Sophia.
It looks like I'm lost at a point where you click on the new to pick your file.
We are not picking a file. We are doing, we are not picking any file. Can you hear me?
I was lost.
I said we are not picking a file. We are starting a brand new thing. So you go to the top, you click new and choose Python 3.
I think at the top when I got that,
those of you who are not talking, mute yourself.
So that's why I think I got lost there. Okay, I'm trying to do it again, Doc.
Okay, so now people are writing on the annotation. Yes, Eric.
Morning, Doc. I really want to understand the in and the open parentheses. What does it really signify?
I have not done any in and open parentheses yet.
But on the interface, where we click the insert down, we have the in and open parentheses before the arrow sign.
I have not clicked on insert. So which insert are you talking about? I just started by clicking on new on the top right, and then I chose Python.
Yes, like this interface, the same interface that we have, where we added more that you can type.
You click on this plus symbol.
Yes, the plus symbol. There's in, then the open parentheses.
Oh, come on. Relax. It's going to give you the number. As you start typing,
okay,
it will give you the number of codes you're having. So you can start typing a lot of code. You wait, when I start typing and you run it, it will give you a chunk of that number. It will give you the number. It will tell you whether the kernel is running. It will tell you whether the kernel is stopped running, and then it will give you the result. So don't worry, for now, I want us to create our kind of space, create the space first.
All right, thank you.
Okay, so if you are done, we are going to type our first command, and we are going to use Python like a calculator. So just type 2 plus 3. Because we are in the code section, type 2 plus 3. And then you can click run at the top, or you can do Control Enter. It will give you the result. You can click run at the top. You can do Control Enter. Okay. Once you do Control Enter, whilst the cursor is blinking there, you do Control Enter. 2 plus 3 will give you 5. So you can do that. That is a first step of writing a Python code. Now, it doesn't matter whether you wrote it 2 plus 3 with a space or without a space. You can do 2. Let's go to the next command. Okay. And then you can do 2 and give more space plus, more space 5 or 3. And then you run it. You run it by clicking Control Enter or click Run at the top here. Once you do that, you get the same thing. Sorry, once you do that, it sees it as, oh, I changed it to Markdown. Please, let me just remove that. So at the top here, it has been changed to Markdown. Remove the Markdown and maintain the code. Okay, maintain it as code. I think you already probably have code there. We'll come back to Markdown very soon. So you do 2 plus 3, even though you have spaced it, okay, it doesn't matter. It will still give you 5, as you can see. So whether there is a space, there's no space, it doesn't matter. You can put it all together or you can change it. But there are other things you can do. For example, you can do divided by. So you can do the next command, 10 divided by 5. And we know the answer is 2. Okay. You click Control Enter, and then you get 2. And then go to the next command. You can type 2 times 2 times 2. Okay. How do you do that? 2 and press star, which is times 2, press star, which is times 2. Okay. And we know that 2 times 2 times 2 is 8. You do Control Enter, and then you get 8 as an output. So you can now see that the in is the input, okay, input 1, and then the out is the output 1. So the in tells you what you are inputting in, the output tells you what you're getting as a result. We are using R basically as a calculator. The other thing you can do is that there are some very interesting things you can do. That is, for example, if you do 2 star star, okay, 3, what is that? Okay, it still sees it as 2 times what do you call it? 2 square. Well, let me change it so that you can get it. 2 exponent 3. Okay, 2 raised to the power 3. That is 2 star star. And when you do that, it's like doing 2 times 2 times 2. That's like 2 3 times. Okay. And that is what you get right here for this. You can use it for several things. Now let's look at another quick way. This is not my interest. Okay. Another quick way is that everything we are typing right now, we are typing them as codes. Okay, you can type things as words, as letters. And I'll come back to that, but let me quickly finish one quick code. Let's say you want to type a string variable by saying print and bring a bracket. Okay? And inside a bracket, bring double apostrophe and type hello world. Okay? Your first usual one that people normally use. Once you do this, because is a word, because it's a categorical, because it's a string, it's not a number, it's categorical variable, it's not a numerical variable. What happens is that R recognizes it as a word, English word, or a sentence. And so you got to put a double apostrophe into it. Okay. Once you run that, it will give you the same thing, hello world, as a sentence. So what you can see here is that you can consider even R as a sentence. To be honest, you can even do something like this. You can even type a poem and type print, okay, into bracket, bring double apostrophe, and inside that double apostrophe, you can bring one apostrophe. Okay. And then in the one apostrophe, say hello world, and step out of that one apostrophe and continue. You are still going to get this one apostrophe coming out of the double apostrophe, because it's a double apostrophe that everything in it is taken. Okay. It's very important to recognize it. So you can see that the one apostrophe actually showed as an output. If I go up there and do another double apostrophe, if I do another double apostrophe here, let me just step out of this. Okay. And I do this double apostrophe and another double apostrophe here. Now you will see that when I should run the output, the double apostrophe will show in the result. For example, if you run it, let me see whether I did it correctly. Okay, so this is an invalid tax. You can use it to write, well, let me just undo this one. And remember that once it's black, once the results comes as black, like this. The result comes as black, indicating that it's a word. So you can use this as a Word document, and I'm coming to that to show you some of those basic things. You can print every result that I did. You can also print. For example, you can print into brackets 10 plus 10, which we know is 20. And you can print that out and you will get 20. Instead of saying 10 plus 10 directly, you can do 10, print 10 plus 10. You can use that. You can represent a lot of things. And I know you've done all of these things with your programming. I'm not so much interested in this. Now, if you want to know the type of a data, so now I have finished the cells. I can create more cells here. If you want to know the type of the data, okay, watch this. If you type something like int, which we know is an integer, okay, and you show this is an integer, but it's not an integer. It is a float variable. So if you tell me that I want you to, I've typed this float variable, and I want you to convert it to an integer. An integer is a positive or negative whole number. So I want this to be a whole number. It will give you the whole number just as you want it. Okay, so you see now I need to create a lot of cells because I'll be putting in a lot of things in there. If you have things, and again, you should check these in the slides. If you want to find the maximum value of all of this, let's say 2, 6, 9, and then 3, and then 5. And then you want to find the maximum value of this, you write maximum into bracket, all of this, and then it will tell you that the maximum value is 9. If I copy the same thing and bring it down here, and then I change the maximum to minimum, I'm requesting for the minimum value, and it will tell you that the minimum, oh, sorry, instead of minimum, I wrote min. Okay, it will tell you that the minimum value is 2. So you can see that our the software Python and with the Jupyter notebook is giving you a lot of necessary information that you want to have. If you need help at any point in time, just type help like that. Okay? And then once you click enter, it will tell you type help bracket. Well, I'm supposed to bring the bracket. Then it will give you whatever help that you need in that particular site. It will take you to the tutorial section. Then you can do so many things with the tutorial. Okay. So this is just a preliminary. There are several things you should do in your programming course. Okay. I'll later do multiple videos on how to learn this thing in your own programming way. But my interest today is not this. My interest is how to load a data file, a Jupyter notebook file, into the Jupyter notebook. And so we are going to do that. Okay. And to do that, let me go up here. You need to go back to the home page. You can see that we were at the home page here, and then we clicked on new. And then that brought us to Python 3 kernel that we just worked on. This time we are going to upload a file. We are going to upload a file. Before you upload a file, the file should be in your My Document. Guys, I've given you a file, and as you know, the file I've given you has a name. The name of the file I've given you is, what's the name? The name of the file
Diabetes.
is Pima Diabetes. Okay, Pima Diabetes. And I called it new. Okay, I called it new, Pima Diabetes new. So that Pima Diabetes new should be in your My Document. That's number one. Number two, the CSV file should also be in your My Document. Okay, that's like the working directory. So both of them should be in your My Document. Okay. Assuming that they are there, and I know you've done it already, you go to upload at the top here. Go to upload, and then click on upload. It will require you to select which file you want to upload. But let me show my entire screen so that you can appreciate it more. Go to upload. Click on upload. And then go to your folder. Okay. Now the folder is My Documents. On the right here, I'll click on My Documents. And then I'll look for, and just watch something, guys. You see that I have the CSV file here, which is diabetes. It's simply called diabetes. Then my Pima Diabetes new, okay, I should have it here. This is it. That's Pima Diabetes new. Okay. Select that Pima Diabetes new. Double click, and then it will come here. There you go. It is showing here at the top here, and then you can upload it. So I'm going to click upload at the top where it is showing. Okay. When I upload it, I have to click this upload there. So I'm going to do that now. And once you click upload, it will upload. And when you come down, look for it. Look for it. Pima Diabetes new. This is it. Pima Diabetes new. It just says on the right that it was done just some seconds ago. Just some seconds ago. So you just now click on it. And that file, that document will open with all of its content. Now, whilst it is opening, I want to just show you something that we did here. You remember that first time information that we're typing? Now, let's assume that I was at this command, and now I want to give a heading to whatever I'm going to do. You can change the code at the top and select Markdown. Once you select Markdown, whatever you type becomes like a Word document. If you want a big heading, do hash, and whatever you type. So let me just type as big heading. Big heading. It it sees it as a big heading. Once you click Control Enter, it becomes a big heading. Let's say that you want a medium heading. Click inside and make sure that you've changed the code to Markdown. Markdown now converts everything to a word and type double hash. So it's not a big heading, but let's say medium heading. Okay. Medium heading. And you run this, you now have a medium heading. Now let's insert some more cells. And then click inside, change the code to Markdown again. And this time we want to write a whole sentence. So instead of a hash symbol that is 2, we make it 3. And let's say that this is a whole sort of sentence. Or sentence that I want to type. And then you can continue and write a whole bunch of information. Once you run it, it becomes a sentence. If you want it to be a sentence, if you want it to be very, very tiny, okay, not like this, okay, just double click on it and change the hash to 4 hash. And now it becomes a kind of a sentence without a bold. The previous one was like a sentence with bold. And once you Control Enter, it becomes a sentence without a bold. Or you can just go there and after this, just type. Don't bring the hash or anything. Okay, and it becomes a normal sentence. Okay, like you have it. This is a way, it helps you to be watching your result and at the same time watching your code. You watch your Markdown and at the same time you watch your code. Okay, now let's go back to our PIMA Diabetes New. All of you should open your PIMA Diabetes New and you will see that it has headings. Okay? When you double click on it, you see that it is actually a whole bunch of sentences. And at the top, you see that is a Markdown. So I've written all the Markdown instructions, everything that you need for you there on this PIMA Diabetes. Okay, so let's try to, and by the way, because I've double clicked on it, everything has changed into Markdown language. Once you Control Enter, it kind of turns beautifully into a sort of Microsoft Word result. And now you can read it. So let's get a bit of the insight into this. Diabetes is one of the most frequent diseases worldwide. The number of diabetic patients are growing every year. The main cause is unknown, yet scientists believe that a major cause is genetic and environmental factors. A few years ago, a research was done on a tribe in America called the Pima tribe. It was found that the ladies are prone to diabetes every year, very early. A lot of constraints were placed on the selection of these instances from a larger database. Particularly, all the patients were females, at least 21 years of old. Diabetes, Pima tribe. So here we have a lot of features or characteristics of these ladies. The pregnancy is the number of times a particular person is pregnant. The blood pressure of the woman, the glucose level of the woman, the insulin level of the BMI, the diabetes pedigree function, the age. And then you have a dummy variable here, which is whether the person is truly diabetic or not. First thing we want to learn here is how to import the necessary libraries or packages. And then we will briefly explain the use of each of these libraries. So number one, you have these things as well. I type this, so you can double click and always type it. You see, I use 2 double hash. So you can see that when you run it, it is actually bold. Now, in there, I change the Markdown from Markdown to code. So everything you see here is a code. Okay. You can edit it, this. Okay. Anytime you bring a hash in a code, it means that you are writing an instruction. Okay. So you do what I'm doing. I just rewrote this correctly, nicely. Write the appropriate library name. Import before you can do descriptive statistics, you need to import some libraries. One of the libraries is NumPy, okay, and we are labeling it as NP. We are also importing pandas, Seaborn, and Matplotlib, okay, .pyplot, which I use it for a lot of graphs. Seaborn and then Matplotlib, all of them are used for graphical visualizations. And since I know that some of you have learned this, some of you may not fully have learned it, so I have also given you instructions, okay? I've also given you instructions on how to get the meanings of this. So what is NumPy? NumPy consolidates handling of numbers and numerical analysis and methods together. It's very good for homogeneous numerical data. Okay. What is pandas? Pandas, from the word econometrics, panel data, okay, is designed to work with tables, heterogeneous data. It's one of Python's library, used for a lot of data manipulations, pandas. Seaborn, as you can see here, I've done a bit of the writing here. Seaborn is Python's visualization library. So I told you before, visualizations. Matplotlib is also a 2D plotting library for visualizations. And all of this, you can read about them, on your own in the center. So let's assume that with all these loaded, so click inside this code and run it. Run it means do Control Enter. And once you do that, you see the star moving. The star is moving. We have a star there, meaning that the thing is a bit slow. Okay. In my case, it's a bit slow. That's what it says. So the fact that you have the star, okay, now it's changed to 1, which means that it has run. Okay. So you have your first code where you have imported all the libraries. Please do that. Do that. The next thing you want to do is to read the data. Remember, the data set, which is known as diabetes, CSV, is inside the folder, your My Document folder. Okay. The same folder that this project Jupyter notebook file is. So click inside here. I've written a little instruction here that tells you what to do. Write the name of the appropriate function if you are importing directly. So this one is important. If you are importing directly from the folder that contains the CSV or the Excel file. So if it is Excel file or CSV file, that's it. I have written it for you, and you should have the command like that. If you don't have the command like that, let me know. But I've given you the whole command. So what we have decided to do is that the name of the data, the CSV, is called diabetes. And we are using this pandas command, okay, that pandas.read_CSV. It will read this CSV file in the data. And we are calling it PIMA. That's the name of the data. You can call it K, you can call it W, you can call it J. Okay, we are calling it PIMA. Okay. The fact that it's black, it's not having a high hash in front of it means it's a code. It's not an instruction. Run it. Click Control Enter to run it. And you can see the star means that it is busy. Now it's supposed to be done. Unfortunately, here shows that it was not done. So let's see why. Normally, when it's not done like that, okay, let me just close this one below. Process delays. Okay. So, where are we? Yes, Michael.
Yes, sir. Please. So I'm using the.
Sir, I was having errors. It says student. I got an error. I posted it in the chat.
Don't worry. You will get an error, but the point that was made by Kingsford is a key point. Okay. So when you have your You see, your folder you must have here must be in, if it is my document, which is where you are working from, that my documents must populate here. Your document must actually be showing itself right here. You must not use the upload and all of that here. Whichever directory, because there's a home directory, which in my case is, and that is where I wanted to work from, instead of working from the documents directory. So go to, if your folder is called document, go and open the documents directory. And then when you open the documents directly, before you upload from that documents directly, if you do that, it works fine, like this.
Okay. All right.
All right. Now let's quickly go and show the last 10 records of the data. The data is quite long. To show the last 10 records of the data, just click inside this code and run it. Okay. Run this code, it will show the results. And please lower your hands.
Yes, I'm trying to do that.
So I just ran mine, and you can see that it is showing the results here. Pregnancy, so it's showing the last 10. The last 10 is 758 all the way up to 767. It will show the data set. You guys are already familiar with this data set. I've shown you a lot. The last section of the data is the outcome variable, which is a dummy. So this gives you the last 10 section of the data. Now you can also show the first 10. So the first 10, I've left it for you to type the 10. So you type pima.head. Remember, the last is tail, the top is head. So click head into bracket 10. Okay. Once you do head into bracket 10, you will now run it. So I'm going to run it. It will show the first 10. I just did. And again, the output is showing the first 10 of the data set. You can see that it starts from 0, okay? And then it continues. It doesn't start from 1, it starts from 0. And then it continues. So the first 10 will be 0 to 9. Just take note of this. So that gives you a feel of your data. You don't have to show all of the data. It just gives you a feel of the data. Now, you can also look at the length of a particular section. So let's say that you want to know how many columns there are. You can go to this command, click on this command, print into bracket length.pima.columns, and then run that. That gives you the number of columns in the data. And the answer down here shows that the number of columns is what? Is 9. And you can count it with your eyes. The thing is, even if you have plenty, this command will help you to always get how many columns there are. If you want to know rows, you can change this column here. You can just change the column here and just type rows. And then it will tell you, oh, sorry, hold on. That type rows or row. Let me just go back and run my column, okay? And then you can go ahead and look at the dimension of the data. There's an assignment you do similar to this. That's why I'm giving you this. The dimension of the data is just telling you the number of rows and the number of columns. It's not multiplying them. It's just telling you the number of rows and then the number of columns. So you can run this dimension, and as you can see, you have 7, 6, 8, and that. Please ignore this one. This one is just an instruction telling you the answer. If you want to know the dimension, just type pima.shape or the name of the data.shape, and that will give you the dimension of the data. You can also see the size of the data. Okay. If you want to know the size is the rows times the column. The rows times the column. So that's what you have here. You can just run it. Okay. And it's 6,912, which gives you the size of the data. We just want to fill the data before we go to the real world. And most important one is here. What are the data types? Okay. What are the data types? So suppose I want to know the data types of all the variables. So each variable, what is the data type? Well, remove this gap, this dash, and type info into bracket. Okay, type info into bracket. And once you run it, it will tell you the data types for each variable. Control Enter. And you can see it here. That pregnancy is an integer, the last section. Glucose is an integer. You can see it as the last column. Blood pressure is an integer. Skin thickness is an integer. BMI is a float. Floats are decimals. Integers are whole numbers. And age is also an integer. Outcome is also an integer. So if you want to know that, and the interesting thing is that it also tells you, the rows, the number of rows or entries that you have. So in this case, it tells you summarily, it tells you that the data types are 2 for float and 7 for integers. Let's move on. Now, what do we mean by missing variables? So let's check whether there are missing variables in this PIMA data frame. If you want to do that, type PIMA dot, is there a null of any of the values? Is there any value that is missing? Once you run this command, I want you to do that, it says false. False here means that there is no missing values. There is no non-missing values. Okay. Now, is null with a bracket. That is a very good, but at times you want to evaluate whether any value is missing. And you want to calculate, by chaining multiple methods together. But for now, this is null. This symbol is null into bracket. It's a very, very good way of finding whether they are missing values. If they are, they will pull it out. Now let's come to the descriptive statistics. This command, okay, we want to find the descriptive statistics for all the variables except outcome. Who can tell me why except outcome? Why except outcome? Because outcome is a dummy variable. Outcome is actually 0 or 1 variable. So finding a summary statistic of a categorical variable is useless. Take note. We are going to be interested more in the variables that are not categorical. So let's run this command. This command says pima.ilog all the way from the first column 0 to 8, excluding column 9, which is the outcome variable. So we are telling it to select the first 8. Once you run this, you will get this result. This result will give you the summary statistics, the count. The count is the number of observations. So here, the count is 768 for all of them, as you can see. The mean value for pregnancy is 3.8. The mean value for age is 33 years. The standard deviation is also there. The minimum value is there. The 25th percentile, the median, which is a 50th percentile, is there. Okay, the 75th percentile, which is also the third quartile, is also here. And then the maximum value is there. So this is a first look of your descriptive statistics. Now, what can you say about any of them? Well, look at it carefully. Look at the descriptive statistics carefully. Look at the average blood pressure. Okay, this is the average blood pressure, 72 point that. Okay, so you have 72 mmHg. The minimum value is 44. The highest is 122. Okay. So that is a clear indication that if you look at the average patient, you can say that the average patient is having a normal diastolic blood pressure. Why? Because it is 72. Okay. And I've explained that here. If you double click this, and you bring this hash, okay, you bring this hash, where is it? You can use it to indicate some of the things. I think this one is not showing. Yeah, if you space it and bring this hash, you can pull out, you can bold in this very sentence. Okay. What I just said right now, you can bold it. I think I don't need the bottom end. You can, in fact, let me make it double, 4 hashes, so that it becomes a bold statement rather. So that is it. The average patient is having a normal diastolic. You see, that statement is having a normal diastolic blood pressure is because you ran it and you got the average and you were able to speak around the average. You can also talk about a 75th percentile, which was 80 for blood pressure. You can see that here. Okay. What does that mean? What does that mean? Okay. That value, okay, is lower. You can see that the average blood pressure is lower than that. Okay. So it means that 75% of the data set is having a high blood pressure of around 80, which happens to be higher than that of the average. Look at the standard deviation of the blood pressure. We are talking about only blood pressure. You can talk about any other variable. The lower standard deviation of 12 shows that many of the blood pressure people, the patients, tend to be close around the average. Now, please take note of this. If you are taking note, write this note. Whenever the standard deviation is lower than the mean, it means that majority of the data are closer to the mean. It means majority of the data points are closer to the mean. But when the standard deviation is bigger than the mean, it means that majority of the data are far away from the mean or far away from each other. So somebody is 1, another is 100, another is, there's a gap, bigger gap, about the data, which means there's a possibility of higher range and higher outliers. So the standard deviation helps you in that regard. Now look at the is there any other thing that we can check? Yeah, you can check several other things we've spoken about, but the main thing is the mean and the standard deviation. You should know what it means. When the standard deviation is 0, what does it mean? Who can tell me? When the standard deviation is 0. When the standard deviation is 0. Don't write this down. When the standard deviation is 0, what it means is that all the data points are of the same number. It means that if blood pressure is 72, it's 72 for every one of these 760 patients. That's what it means. If the standard deviation is 0, it means that all of them have got the same observational value. That is why when the standard deviation is small, we say that they are closer. But when it is bigger than the mean, we say that they are far away from each other. So just the descriptive statistics is telling you something about the data set. It doesn't matter whether the data set is million. Netflix is churning a lot of information that is in millions and trillions. Now let's go to some plots. We are going to plot blood pressure. Okay, remember, we are talking about so many patients, 768 patients. We are going to plot the blood pressure to make some sense of it. To do that, use this command, okay, SNS, that's the Seaborn command, .displot PIMA blood pressure. This kind shows that you want to show the kernel density estimation. KDE is the kernel density estimation. So we are going to plot it and show the kernel density estimation. The first one is this. So run this. It is showing, and here you go, it has shown. So this gives you the distribution for blood pressure. Guys, look at it here. It's labeled it. So these are some beautiful things that you should run. So when I give you your project, you would have to run everything with your words. You don't need to copy and paste it to words because you are only submitting this version. That's what you're submitting with the result. And that's all you're submitting to me. Okay. So look at this kernel density plot. It's beautiful. And it tells you that most of the 768 patients, okay, their blood pressure is approximately normally distributed. If you look at it carefully, it appears to be normally distributed, which implies a majority of the blood pressure values are clustered around the mean. Okay. It has one mode. If you look at it, the mode is one. There's a long one, and that means that it's unimodal. If the modes were two, like this, okay, you have this one, then you have another one, or were three, which is multimodal. Okay, multimodal will be something like that. Unimodal is just one mode. Okay. So that tells you that it's normally distributed with a unimodal. Now, if you look at the skewness, the skewness are here. If you look at the skewness carefully, you will see that it is very tiny. The skewness are very, very tiny, as you can see. Most of the values are tipping off as they move towards the left, and as they move towards the right from the center. They are dying off. They are moving asymptotically towards the x-axis. So the graph is a clear bell shape. And that is a graph. It doesn't mean that it is true unless you test it mathematically. But that is just to tell you the look of this. Because most of the time when I tell you to generate the kernel density, I'm also telling you to comment on it. So don't just generate, but also comment on the kernel density. This is another graph you can use. It's called histoplot. Histplot. Histplot, it will give you, run this command, by the way. It's the same thing. This time you bring the name of the data set. The x-axis is still blood pressure, and it is still going to show the kernel density estimation, which is true here. And this is it. This one gives you both the histogram as well as the kernel density plot. This one is good because at least it gives you a sense of the fact that this thing is truly normally distributed. There's a bit of ups and downs, but it doesn't really matter. The kernel density clearly shows that it's bell-shaped. So that's how you draw, visualize, a particular aspect of a variable. Let's go to the BMI. Okay? The BMI of a person with the highest glucose. How do you find that? If you scroll through, you struggle. So the way to look at it is by this. Type PIMA, which is the name of the data set. PIMA, I want you to pick the glucose level of the person with the maximum glucose. So that word maximum BMI, I want you to tell me the person with the maximum BMI. And this is a command to use. Look at the command very well, so that the first part of the command before the equal to symbol is the glucose data set. The second part of the command is the glucose of the one with the highest BMI. So you are picking the one with the highest BMI from the entire glucose section. So as you know, the glucose section is plenty, vertical 768. You are picking the one with the maximum. Run this command. And when you run this command, you will see the value clearly. Okay. You will see that the person with the highest glucose is person number 661. The glucose level of that person is 42.9. And this data type is a float, which means it's decimals. Finish. What is the mean? What is the median? What is the mode? What is the skewness and ketosis of the BMI? This entire BMI. What is, take BMI, forget about blood pressure now. What is the mean? Well, this command, M1, you can use it to find the mean. Okay. In fact, I'm going to run all of this. All of that. And it gives you all of them. 32.45. This 32.45 is the mean. The median is 32. Okay. The mode is 32. So it tells you clearly that there's a bit of normality. And by the way, normal distribution is when the mean is the mode and the median. That's normal distribution. The mean is equal to the mode is equal to the median. That is a pure normally distributed symmetric data. And the skewness and the ketosis are also shown as 0.92 and 0.61. So the question was, discuss the measures of the central tendency. Well, you can discuss it that they are almost all the same. The median and the mean are exactly the same. A clear indication of normality symmetry in the data set. Let's go to the next one. When you run these things, talking about them, you will need to use the document and the textbook to guide your thought process. The next one, how many women's glucose levels are above the mean? It's a very tricky question when you understand it. So first, I told you, take that of the glucose of everybody. Now, this glucose of everybody, let's take the mean glucose value. The mean glucose value. The Pman glucose value is this. Okay. The shape tells you the number you are looking for. So how many women's glucose level are above the mean? We know that the mean glucose level should be calculated. So if you know the mean glucose level, this greater than says are above. Okay. Above. So there's 343 women's glucose level that is above the mean level. Of course, when you go and check the mean, you see the mean level. If you start counting them with your eye, you struggle. That is why you got to use this command to be able to find your results. And then, of course, you can put down your results here. Let me show you the results of that answer. So this is just to give you some of the results. So here, 343 women's glucose level are above the mean. The next question is, how many women have their blood pressure equal to the median of the blood pressure and their BMI less than the median of the BMI? It's a very, very interesting. That word end, even end, okay, the R code will command it, will commandeer it. So look at it. The first one is equal to. So how many of these women with blood pressure have their blood pressure equal to the median? That is this one. Blood pressure, have their blood pressure equal to the median. Okay. And then end, we use an end symbol. How many of these women's BMI, this is the BMI, is less than, and the less than symbol is on my right here, is less than the median of the BMI, the median BMI of this woman. If you run this correctly, okay, the results will show you here. You would surely be able to see all of this and count it by yourself, because now it's giving you those portions selected. This is woman number 14, woman number 93, woman number 205, all the way up to woman number 765. So it gives you, so you have to now look at what you have here and then count it. And when you count it, you see that you have 22 women. They have their blood pressure equal to the median. And then they have their BMI less than the median BMI. Yes, Michael.
Yes, sir. Sir, please, is there, since the question is asking for how many women, is there a code you can write to actually give you the specific number of women instead of giving you the full list? Or give you the full list and give you the number of women as well?
I'm thinking about the same thing. I think that it is possible. I've not looked at that possibility. I've not looked at that possibility but when you have days, you can equate this one, you can set this one equal to maybe a letter K and say that count K. Okay. I don't want to try it now, but you can check it. You can find a count K, the count of that letter to see whether I can give you the 22 straight away.
Sir, please, I was asking because of the previous question, which we were able to use the dot shape intersect O. Will it give a different value?
Well, the previous question was dealing with one situation, isn't it? The previous question was dealing with the glucose level of women above the mean. But this one was dealing with, say, the glucose level of women above the mean and that of those above, below the, So it's giving you something that is of two scenarios. You're combining them. That's why you can see that it has the end here. What you can do is you can run the first part like the shape one. Okay. You can run the first part like the shape one, see the result, and then see whether it will give you the exact number. I don't want to do it here.
Yes, I did it. I just put it at the end, and then it gave me 22. So at the end, after the median one, the very far end, dot shape intersect O.
Yes, so let's just go here and enter a sheet.
Okay.
You put it into the bracket here.
No. This was the very far end. The very far end.
Which one?
So on the code line 18, where you run the code, it's after the very end. So like the very
after
end
the
of the
end, you added dot shape.
Dot shape, yes.
You mean after the square bracket?
Yes, after the square bracket, dot shape O.
Oh, okay, I get it.
Or dot shape 0, yeah.
Okay, so let me just delete this one. Yes, it's good. It's good that, like I said, some of you have. All right. So let's run this.
It was a square bracket.
Oh, yeah, that's a square. Yeah, like this. So it gives you the number straight away. Okay. So the same way, it means that if you go run this, instead of having the 343, if you run this, you get the whole thing. If you add the dot shape, whatever you're looking for, you get the number straight away. Guys, I mean, this goes to all of you who are running it just so that you can get the answers straight away. Very good, Yabwa. Is it Yabwa? Yes, Yabwa.
No, it's Michael. Income.
Michael, good. All right. Let's go to the next one. Create a pair plot. A pair
Hello,
plot.
Prof. No, Prof. I have a question.
Yes, go ahead.
Okay. My question is, could you please? Okay, so I saw that with the comparison operator, which is equal to the PIMA blood pressure. All right. I know that most of the operators have level of priorities. I wanted to ask, wouldn't it assume that, okay, because we are starting the code from the left-hand side, it will execute the PIMA into bracket blood pressure is equal to PIMA blood pressure first before it adds the PIMA BMI less than PIMA BMI, because there is no into brackets from there's no bracket, close bracket from the PIMA blood pressure dot median. I don't know if you get what I'm trying to, because of, I was thinking it will execute the first part of the code first before it goes to the second part of the code, which continues from the end, which might actually give us maybe a different answer. That is what I was thinking.
Did you run that? Did you switch them to see?
My destiny is not, my laptop is not helping at the moment, so I'm not.
Then when it helps, then you try that. Okay. I like different flavors, but I don't want to be running everything here because of the time. Okay. So run that and see whether it works the way you said, and then let us know in the group and discuss. All right, create a pair plot of the variable glucose, skin thickness, diabetes pedigree function. Create a pair plot. Pair plot is like a correlation matrix. A correlation matrix of the graph, like a scatter plot matrix. Okay. Now, how do you do that? You can use the cbon command. Cbon, pair plot, the name of the data, the variables in question are all of this. Hue is the position of that. So you are separating all of them by the outcome variable, which is actually a dummy variable. Okay. And then this PLT show will show the results in that. So run this command. Just understand the command, but run the command. The star means that it is busy running. When it is done, the star will go off. And that is your pair plot. Okay. So first, you can see that it is giving you a plot of one, a plot of, what is that? It's giving you a plot of the histogram of kernel density, a plot of the scatter plot as well, for each one of them, separated by whether the person is diabetic, which is 1, or is not diabetic, which is 0. And it does give that for glucose, it gives that for skin thickness, and then for diabetes pedigree. Okay. What can you say about this variable? What can you say? Well, the pair plot, we chose only 3 variables. So there are so many things you can dictate. 1, the diagonal, you see the kernel density is showing in the diagonal, all of them. The kernel density is showing in the diagonal. That's a 1 observation. And looking at the diagonal and the scatter plot, it shows and appears that a diabetic patient, which is those with 0, tends to have more glucose than non-diabetic patients. How do you see that? A diabetic patient is the blue one. The non-diabetic patient is the orange one. And just look at the first one. A diabetic patient, which is a blue one, the kernel density is bigger than that of, or is higher. In all cases, the diabetic patient has got more glucose, more skin thickness, more diabetes pedigree, because the blue one is above the non-diabetic, which is the number 1 one. Basically, both patients have similar skin types, similar likelihood of diabetes due to genetics. Now, here, it is slightly above, but it's similar. If you look at the way it looks at in terms of the shape, that is what it's saying. And then, of course, there are more of the non-diabetics with lesser glucose. We've said that, okay, based on the scatter plot. Let's see that. If you look at this data set, you see the higher the variable, the better. So if you look at the data set, the orange ones are above. Look at the glucose level. It's from 50 to 200. The orange guys are taking the bigger values. Okay. That is what we are saying, that the non-diabetic guys, okay, are exhibiting, what do you call it? Exhibiting lesser glucose than the diabetic guys in terms of the numerical structure. And you can see that numerical structure from here. Now watch it carefully. Each one is showing the relationship between one and the other. So for example, this last one here, the last one is showing the diabetics pedigree function relative to diabetics pedigree function. This first one here is showing the glucose level relative to that, the glucose level, and it's the same thing at the top here. Whatever you see here at the top is the same thing. Diabetics pedigree function and then glucose pedigree function is the same thing here, but it's switched the opposite way. There's the same thing here. So you can see that at the top here, the orange colors are showing deeply. That orange colors that are shown deeply, they are the ones showing deeply here rather. No. It is a mirror image, but in an opposite direction. The graph is a mirror image, but in an opposite direction. When you compare this one, it will give you a better understanding. So take, for example, this one. You just do that. This one and this, they are mirror images, but they've swapped in an opposite direction. Yeah, somebody is now cleaning the thing for me. Let me just go back and prevent that notation for others. All right, so that's it. And then there appears to be no relationship, obvious one, between variables except the slightly positive link between glucose and that. Okay. I've just decided to just give you a bit of write-up for you to know that it's not just visualizing, but also commenting on your visuals. Now let's go to the next one, how to plot the scatter plot between glucose and insulin. So first, let's plot and then comment. Okay. Use this command. Again, the same seaborne scatter plot. The x-axis is the glucose, the y-axis is the insulin. And then show the results. This is a scatter plot. Clear, beautiful scatter plot. Insulin is on the y-axis, glucose is on the left axis. What can you say about it? Look at it carefully. If you can see, there is a move shifting away from the insulin towards the glucose section. Okay. There's a lot of density on the glucose section, you know, at the higher level than on the glucose section at a higher level. So glucose is slightly positive, and you can see that there appears to be a positive relationship, but it's not that much. Slightly positively related with insulin. Normally, I don't buy this until I use numbers. But what this means is that as glucose are rising, insulin are also rising, but they are rising slightly. It doesn't mean that there's causality. They are only related. That's a key point. It doesn't mean that the one is causing the other, but they are only related. So the scatter plot can give you a fair idea. Now let's look at box plot of age. Box plot is another beautiful visualization. Now guys, take note, check the note. You'll see it in the note. The box plot gives you a 5-number summary of the variable. The 5 numbers are the maximum, the minimum, the lower and the upper quartiles, and then the median. A box plot gives you the 5-number summary of any variable. If you check the box plot, it can help you to detect whether there are outliers or there are no outliers. It will pinpoint it. And it's one of the great advantages of the box plot. Another plot that does that is called the violin plot. The violin, that is even better. That one goes beyond the measures of central tendency and also shows you the distribution of the data. So it's like a combination of the box plot as well as the kernel density plot. That is violin plot. Okay, so let's do the box plot of age. Okay. So this one will give you the box plot of the PIMA age, and this one will give you the title. The y-axis will tell you that it's age, and then you can show the results. This is it. And clearly you can see that there is a whisker. The whiskers are the things that are between the horizontal and then the 75th percentile. The orange color is the median. Above the whiskers, now you have the gap here, which is the outliers that are shown here. So what can you say about this? When you look at age, it shows that some of these women, they are quite old. Okay? They are outliers in the data. Some of the women are quite old. You know? And they are located outside of the whiskers. So ages outside 1.5 times the interquartile range. Above the upper quarter and below the lower quarter. So those are the outliers that you can see. But clearly, it tells me, when you look at this first box here, the box here tells you the majority, this is 50% of the data set. And the mean is not even in the center of that 50% of the data set. So that, and this is for only age. Take note, it's not for blood pressure, it's for only age. You're able to have that feeling there. Now, finally, let's look at a histogram of age. Okay, histogram. We've done histogram of some of the other variables. So looking at the histogram of age is not bad. If you look at the ages, when you look at the histogram, you see that those who are below, okay, those in the ages of 20, they are getting higher level. They are much more frequent in the data set. You can see that there. Let's plot this same thing by changing the bins. That's another way of looking at it, to check the distribution. And again, the same thing. You can see that those between the age of 20 and 30. So both histograms starts from 21. Because of the sampling bias, you can see that the data set is just made up of women above 21 years, if you can remember. So it's like you have deliberately cut off some women. The data is censored, okay, truncated from below. So patients or these women are in the ages of between 20 and 33. These women are the dominated one. Okay. They are the ones with most non-diabetic and diabetic patient group. But if you look at the data, if you look at the graph, there's a sharp fall in the age concentration among the non-diabetic patients. As you can see, as the ages are increasing, okay, among the diabetic patients, there is a reduction in the number of non-diabetic patients over time. So there's a greater disparity or a more spread out in the ages of the diabetic patient, which is more left skewed. Okay, so the first one here is a diabetic patient here. And then the second one is a non-diabetic patient here. I wouldn't use this, okay? I would normally use a kernel density plot. Okay? But I just wanted to use something to show you. A kernel density plot will give you a better analysis. Even a box plot will also give you a better look at the data. So you can check other plot for yourself and see. But you can see that the non-diabetic patient is more skewed. Look at it. The diabetic patient is not that tailed. But when you look at the non-diabetic patient one, you can see that it's more tailed to the right. It's more right skewed than the diabetic patient. Finally, calculate the interquartile range. Interquartile range is simple. You calculate it by the third quartile minus the second quartile. That is the 75th percentile minus the 25th percentile. This command will do that. Run it, and you can calculate the interquartile range for everyone. Okay, you can do that. You can calculate the interquartile. You can calculate the 90th percentile for everybody. You can calculate the 80th percentile for everybody. But what is the essence of the interquartile range? It's used to measure the variability or the skewness of the data. And it's mostly used when the data is not normally distributed. Data that tend to exhibit more outliers than data that is more approximately normally distributed. Interquartile range is used to measure that. And the box plot visualizes the interquartile range. When you go and check the box plot, this is a box plot, and you can see that the gap between the upper part of the box is the 75th percentile. Then the line or the lower part of the box is the 25th percentile. The interquartile range is the entire space between the box, upper and lower part of the box. That's interquartile. Okay, now finally, let's look at the correlation matrix. We shall come back to correlation matrix in the next 3 weeks, but let's visualize it. This is a graph visualization. You use this command called call matrix and then run it. We are not doing the correlation matrix for the outcome variable. It's just the integer and the float variables. This is a correlation matrix. This is a correlation matrix. This is normally done before you do regression. This correlation matrix will give you 1, 1, 1, 1, 1, 1, 1, 1, 1 for all the diagonals. because the one is showing the relationship between pregnancy and pregnancy, glucose and glucose, BP and BP, and on and on and on. You can see the correlations here. Okay. And there's a beautiful story here. Let's look at a graph of the correlation. We've done the table, but let's look at the graph. That's the last command. This correlation, let me tell you what is good about it. It doesn't only tell you the numbers, but also tells you with colors. It tells you with colors. So these colors are very, very good because they tell you the intensity of the matter. By the way, the whiter, the brighter the color, the greater the correlation, the stronger the correlation. So when you look at it, those that are one are very, very white or creamish, followed by those that are reddish. Okay. Those that are reddish are the next ones, like between skin thickness and that of, what's the other one below? So you can see that between skin thickness and BMI is red. Okay. Between pregnancy and age is also red. That is high. Now those other 111, they are not high, they are perfect. They are not high, they are perfect. So you can see some kind of relationship between some of the, for example, if you are, there's a strong relationship between your age and then your pregnancy level. There's a strong relationship between the thickness of your skin and your BMI level. So this gives you some bit of an idea. And then you have black. Okay. Those black will show some things. In fact, before the black, you have the purple. The purple. The purples are the next one. No, before the black. Before the purple, you have this one. I don't even know what color that is. Ruby. That ruby color. Okay. That ruby color before the purple color. It's from red, then to ruby, then to the purple color. This we shall do, but this is a beautiful correlogram or a scatter plot matrix or a picture of a scatter plot, a correlation matrix. That will correlogram that will help you to know the relationship between each variable numerically, not just scatter plot, but numerically with the numbers attached to it. So normally when you generate this is good, but it doesn't show you the p-values. You need to check the p-values to determine if the correlation is statistically significant or is not statistically significant. Guys, this is how you execute. You execute a descriptive statistics with other things in Python. I want you to go over this and then understand it. If you have a question, you just let me know. Because I'm going to give you a data set just like this, and everybody will work this data set, and then we'll submit it in a format like this Jupyter Notebook project. Very good. So that brings us to the end of our meeting for today. If you have a question now, please let me know. If you have a question now, let me know. Do you guys understand and remember why I said you should load your work before you come and all?